Within Out is a collaborative piece of interactive installation art. The work was a piece that was part of a wider show called Manifold that was shown between mid-July to September 2016 in the Pyramid Arts Centre in Warrington. What's really interesting about the Pyramid is that it's a multifunction space, and part of what we were trying to achieve was to make the perception of the space change by the work that was in there. So the work was a collaboration between 4 artists: myself, Dan Wilkinson, Tracy Hill, Matthew Birchall and lashley-burnley. The work was a collaboration between 4 artists plus Magda Stawarska-Bevan. We essentially curated the space. So we were commissioned to think about making work that was about the space. I had this idea of working with the sonic characteristics of the space, but then making work that fit within the space. So the initial idea was to record sounds within the space and then replay them in part of the space as well. So the piece utilises sonic hemispheres, projection mapping, sensor-based AV changes in the gallery context, which in turn creates a unique experience in the gallery. And the idea I was trying to come across with was this thing of voyeur versus participant. So the sound in the sonic hemispheres behaves very differently. As you move your head around, the sound changes, reflections become localized, amplified, and essentially it's like being in a satellite dish whereby all of the sounds are reflected back and amplified and combined. Not only was I using hemispheres, but these hemispheres actually had a transducer attached to the top of them. So the hemisphere itself starts to act like a speaker cone. So a speaker cone is paper vibrating and oscillating, moving. And my idea was to attach the transducer directly to the hemisphere. Therefore, the hemisphere itself becomes the speaker cone. What was really interesting was that when different frequencies were put through the hemispheres, then they behaved in really different ways. So there were certain resonant frequencies that really made the hemispheres vibrate and oscillate in a really amplified way. The hemispheres themselves had sensors within them. So the idea was that when a participant went into the gallery and put their head inside a sensor or just went underneath a hemisphere, a PIR sensor, a passive infrared sensor, detected a participant and then started playing the sounds in the sonic hemisphere. Not only were sounds triggered, but projection mapping software was being used via projectors, and that was a thing called Resolume. Initially I used ultrasound sensors. They were really sensitive though. Once I wired up more than 4, they'd behave really strangely, so I came to the conclusion that I might be better using a different sensor. So instead of using the ultrasound sensors, I changed them to PIR sensor, the passive infrared sensors. I've used them before on quite a lot of projects. They're just powered 5 volts and then they have a signal output. The sensors were linked directly into an Arduino microcontroller, which is just an input-output device connected to the software. The transducers, as you can see on this picture, are quite hefty. They look like the magnet on a speaker, and then the white bit on the picture was directly attached to the hemispheres. I used some little amplifiers, and they have digital or analog controls. For this I just used the analog controls within it, but you can control amplitude via digital means. And the setup was essentially a PIR sensor through the Arduino into max-msp software. That then controls the sounds being triggered, but it also sends OSC, Open Sound Control, commands to Resolume. And then Resolume sends the visuals out to a projector that are mapped onto each hemisphere. that was something I'd not done before. It was really good because you can specify what part of Resolume you want to control with the OSC commands. With regarding max-msp, essentially that was just getting serial port data, which then triggered sounds within it. There were 6 input pins on the Arduino, and then what I did was had initializations for each pin, which were even numbers of 0, 2, 4, 6, 8 and 10. And then what I did within the code was go, if a PIR sensor is triggered, i.e. a high value, for sensor 1, then send out a 1 as a value. If it's not triggered, if it's low, then send a 0 out. And then sensor 2 was high was 3 and low was 2. Sensor 3 was high 5, low 4. So if it sent out a series of low odd numbers, that meant that the 6 sensors were triggered. So 1, 3, 5, 7 and 9 were trigger values, and 0, 2, 4, 6, 8, 10 were non-trigger values. Slightly clumsy, but it just worked. It looks quite complicated, but it's just repeated 6 times. In the top left corner, you've got a place where you load a sound file. So I had a whole bank of sounds, and then what happens is there's a randomizer. So the way it works is I put all of my sounds, there's about 30 odd sound files, you put all those in a folder. When a sound file's triggered, it plays the current sound file till the end. And then at the end of it, it sends a bang out to randomly load another sample within that hemisphere. So you get this kind of randomization of sound. Within it as well, there was, the signals coming in on the Metro, on serial C9600, and that's where it's getting the odds and even values from the Arduino on the serial port. It's been outputted through a multi-channel sound card, so it NICs a 6-channel sound card, so each channel is going to each hemisphere. That's also sending the messages out to Resolume via OSC, Open Sound Control.